Another option under Setup is Calibrate. This is used to calibrate the position for our injector, our clamp. We also have a pressure sensor on the hydraulic manifold, and we also have the proportional valve, which is how the PLC controls pressure in the manifold. So calibrating the injector and the clamp is not very difficult. One of the things we'll see on both screens is what the current position might be. So this is the analog signal back from the linear pot, and we've scaled this to inches instead of the raw counts. So at the top here we do have raw counts. So our 0 to 10 volt signal has been converted, comes in as 0 to 2,000 or 27,648 counts. Currently we're reading nothing. Due to the scaling of the system, it's saying 0 would happen to be 0.66 inches in the negative direction. To calibrate the system, the best thing to do is drive the injector to some known position. For example, an injector, we can drive it all the way down, which would be 0 position, which in this case we're showing a minimum position of 0. At that point, I would look at the raw counts being read back by the linear pot and type that in on the minimum counts. Same thing as I would drive the injector all the way up, which again, we only have a 3-inch stroke on most of our injectors. So at 3 inches, what is the value I'm reading there? In this case, I read 27,288. I type those two numbers in, and the system automatically scales for that stroke, and that's all you need to do. So I just need 2 positions in the travel of the injector and document that here, and then it'll scale everything for me. Ideally, though, when you're adjusting your linear pot, you want to make sure that you are not in any form of dead zone for the linear pot. Even though you are still able to travel up and down on that linear pot, you do want to watch your raw counts. You do not want to be anything near the 27,648. In this case, I'm a few hundred counts below that, but I do want to be able to see that as I'm moving the injector up and down, I am seeing my counts adjust. If the counts are not updating anymore, you're into the limit of the linear pot, and thus you might actually have a dead zone and not actually be able to see anything accurately. On these screens, I also give the ability to do jog controls, so obviously it's more convenient if you're trying to move between a minimum and maximum position. It'd be nice to have the jog controls right here to be able to move that axis up and down at this point. The clamp screen is not much different than what we saw on the injector screen. The calibrating the pressure sensor, same concept, but pressure sensors, at least the GEMS pressure sensors we're using in the machines, are already calibrated from the factory of 0 to 3,000 psi, and it's translating to 0 to 10 volts, which is also the 0 to 27,648. It's already scaled from the factory. I don't need to do anything. I just type in my values right here, and everything's taken care of. There really should be no reason in the field you need to readjust these values. One of the last ones, which probably is the most time consuming on this machine, would be the calibrated proportional valve. So again, we have the ability to see what the calibrated pressure value is, so what we've taken that 0 to 10 volt signal and what we think we're sending out. And we also have the raw counts. Now again, on this version, we're not getting an analog signal in, we're sending an analog signal out. Calibration data is the same, but what we do here, how we calibrate the system, kind of involves moving the carriage up and down in this override. So typically when we calibrate the proportional valve, one of the first things we have to do is set the pressure limit on the actual pump. To do that, what we'll do is we'll take our manual override and set it to the 27,648. So what we're actually doing at this point is we're going to send a 10 volt signal out to the proportional valve. In other words, open up as wide as you possibly can. And I'll turn on the override, so override has to be on. So at this point, I am sending out a raw count of that. If I turn off override, you'll see it go back down to some lower number. So with the override on, we're sending out 10 volts. At that point, I will also jog the carriage up. Typically, it's the easier way to do it is just take the carriage away from anything and just drive it up. At that point, you can mechanically adjust the pressure relief on the pump and get it set to typically about 21,000 psi or 2100 psi. So at that point, we set the maximum pressure the system could ever see defined by the pump, and we're eliminating the proportional valve in that loop. Once that's set and we have the maximum pressure set, we can turn off the override. And typically though, since I drove the carriage up and I did it at the maximum pressure of the system, which would have been 2100 psi, the system has a built-in kind of like check valve that kind of prevents the carriage from moving. So I have to actually, I can't have the pressure or the carriage try to drive back down with only like 500 psi. So I might leave the manual override on and drop the value down to like 10,000 counts and then drive it down, and that will give just enough pressure to get the carriage to move forward, because if it's too little of pressure between the 2100 and what you try to do next, like 500 psi, it's just not enough to move the carriage. So you have to kind of set this to a little bit higher than what you normally would do. And once you do that, you can turn the override off, and then the machine should jog up and down normally. Now, dialing in the calibration data, again, we shouldn't be changing this too often, but you might have to tweak it a little bit. And this involves, again, what's our minimum maximum counts, and then seeing what the pressure is. So what we do here is, instead of jogging axis up and down and seeing what the pressure is, I will manually override the system. For example, I will type in 8,000 psi, and I'll drive the carriage up. And then I will look at the pressure gauge on the machine and see what I read. In this case, I might have read 550 psi, so I'll type that there. And my next step is I might try 1500 psi and then jog the carriage up and look again at the pressure gauge on the machine and see what it reads. I could also look at current pressure, which is up here, which is the current pressure. The current pressure is down below here, and that's actually coming from the GEMS pressure sensor, and that one's pretty calibrated too. You could also use that as your reference if you don't want to look at the glass gauge on the machine. But in either case, I need to force the system to some counts and then see what it changes to based on how I drive the carriage up and down. Another thing to be aware of for setting up the machine, so on our proportional valve, there are parameters. So we actually have to, the first time we power up the machine, pull the cover off of the proportional valve and adjust the high level parameter from 0.1 amps to 0.6 amps, because again, the proportional valve we buy is capable of moving between 0 and 0.6 amps, which is also tied to our 0 to 10 volt signal out of the PLC. If you do not set that parameter to 0.6 amps, you will not get the full control of what you expect out of that proportional valve. One of the last things you have for calibration is calibrating the touchscreen. Again, this is just calling up the option off the HMI to calibrate the actual touch of the screen. Some screens might need it. Typically from factory default, we don't need to do this too often.